Warm regards everybody. The topic of today's presentation is QSWAT Hydrologic Modeling Software Customization for Watershed Characterization Study of Lough Neagh Watershed in Northern Ireland. It is to be noted that the study area is outside of United States. That is the reason we have to customize software to make the QSWAT model work. And Wyatt Wilcox, my student, who is now pursuing his master's in Oxford. So he developed this project and I'm presenting this one. So a background, soil and water assessment tool model is about like modeling the small watersheds to river basin scale, and it actually simulates the quality and quantity of surface and groundwater and predict the environmental impact of land use, land management practices, and climate change on the watershed. SWAT is widely used in assessing soil erosion prevention and control, non-point source pollution control, and regional management of watersheds. SWAT is a vital tool in the assessment of watershed health and the cataloging of watershed resources in the preparation of watershed management for stakeholders. SWAT model is a versatile model or tool to implement, to quantify various watershed other elements. Many output layers can be generated from the SWAT model, and we actually use QGIS to kind of host the SWAT, which is known as QSWAT. QSWAT 1.9 was downloaded and loaded as an it worked on this QGIS 2.6 platform. And the study goal, so we had one kind of very defined goal for the study. So it was to present our study through QSWAT software by customizing it to run it on the open source QGIS environment, so that we can assess various environmental factors in the watershed, that is the southern portion of the Londonderry County, Northern Ireland, United Kingdom, near the town of Magherafelt, west of the Upper River Bann and the northern boundary of Lough Neagh. So designed study objectives. So number one, to design and implement SWAT model for the Magherafelt subwatersheds, and also to model the area of interest in QSWAT, which is an extension of the open source QGIS Brighton 2.6 software. At the end, the model will provide support for watershed and environmental managers using the QSWAT result for the area of interest environmental decision support system for watershed management. So this is the area of interest in the right side. You can see this entire Northern Ireland portion is not our area of interest. A small watershed is. It is Magherafelt Northern Ireland watershed in United Kingdom, and the area is of importance to watershed and catchment studies in Northern Ireland because it is having diverse topography. Soil types in the area is also heterogeneous, as well as the riparian environment connected to River Bann, which feeds into the Lough Neagh and the largest freshwater lake in the British Isles. So you can see that one is here, one of the largest inland lake. And common estimates are that the Lough Neagh supplies 40% of Northern Ireland's water. So that is the reason the watershed that supply water to Lough Neagh need to be properly managed, and this study is the first step to provide the watershed managers to really manage it well. So as such, the watershed in this study's AOI is of critical importance, to the overall study of Northern Ireland's watershed management, because 40% of Northern Ireland's water comes from Lough Neagh. So this picture shows the watershed that actually provides water to Lough Neagh, which is providing 40% of the water need for entire Northern Ireland. So data preparation was the very first step of our customization of the software, because as we explained earlier, the study area is outside of United States. So we created all the data layers required for this modeling in the TM65 iris grid. Those are projected in TM65 iris grid. We created a 30-meter DEM, downloading it which is created using NASA's SRTM data, that is shuttle radar topography data, and we use the 1 arcsecond resolution data available to us. The soil raster was digitized and rasterized using available soil PDF file, because it was really not easy to find vector or raster data for the soil. So the hard copy was available, and we digitized and rasterized it for our purpose. Another drawback was also the land use file. So the land use file, just like in United States watersheds, we use the NLCD data, which is already classified and your ground truthed. But this one, we just downloaded the Landsat 8 data and classify using isocluster unsupervised classification method, and classified with 4 classes. Classes were like generalized land cover classes: forest, number 1, number 2, agriculture, number 3 was pasture, and number 4 was water bodies. All layers were clipped to the watershed boundary, that is the 1993 political boundary layer available from the Ordnance Survey of Northern Ireland open data site. And this is an example of the 1 arcsecond or 30-meter DEM created using the SRTM data. This one is the 4 class land use, your Landsat 8 classified data. And this one is the AOI soil data. You can see that the soil is very crude resolution, only 5 classes are there. And this is also a tricky situation we came into, because generally in SWAT model, either for United States StatsGo or SORGO or GSORGO data is used, and the MUID is one of the criteria to link the soil data to the SWAT model. But here you can check we have 5 different soils. Those are mostly the orders, top order data, and pluvisols, glacisols, histosols, stagnosols, and camisols. So those are the order data. It was very we really worked on to customize it to SWAT model, and it worked. Then watershed delineation process was followed. Watershed were delineated with an emphasis on major streams within the AOI. The DEM was used to determine streams, channels, and rivers, and we created 41 sub-watersheds. And this is a generalized watershed delineation setting. Whether you use QSWAT or you use map window SWAT or you use ArcGIS SWAT or ArcSWAT. So now check that one important thing, we actually defined the threshold as 5.996 cells, in square kilometer, which is 2569 cells, means the smallest sub-watershed will be 2569 number of cells, or 5.996 square kilometer area. Thus we got 41 sub-watersheds, and also some intense stream network got. So you can see the delineated streams. It is not that too intense, but it is intense than whatever available to us earlier. And this one is the 41 watersheds. And once we got the watershed created using the DEM, so we got the soil data and the land use data introduced to the model, and model actually using soil, slope and land use data created the HRU. HRU is a hydrologic response unit, and each HRU has the unique soil type, slope type and land use type. But that provide like a lot of HRUs. It will be very difficult to analyze. So that is the reason we made it filtered using the dominant category option for the model. So that way it created less number of HRUs. Then next critical part was weather data, because it is out of the country and finding weather data is also a tough process. But lucky for us, your SWAT model database contains a global weather database, and the global weather database luckily we had one weather station inside the or middle of the watershed or area of interest we are using. The data, weather data was available from 1994 to 2014, almost 20 years, not bad. But the tricky part is we have to customize it for the QSWAT software. So we customized, we created the database for relative humidity, solar radiation, wind speed, temperature and rainfall, and then provide as input to the your SWAT software. And other inputs were used as default, that is available through the SWAT software. And then we run the QSWAT model, and our setting was from January 1, 2015 to January 1, 2025. And we use 64-bit release version for processing speed. And you can see the graph like your figure here. And we did monthly simulation. Now you can see the first result. This result shows the stream network, which is having how much flow. The wider or the darker color in blue is having higher amount of flow, and it is understandable, like your tributaries always contribute water towards the end of the main river. So main river has higher flow and it is quantified, and this result in your centimeters. Then the next result is the sediment load, because sediment is or sediment loading or total suspended solid in the water actually determine the water quality, and it is one of the biggest feature for management, watershed management decision support system. As the watershed actually your confluence, the water up from the watershed goes to the Lough Neagh. So if more silt goes through the river to the lake, then the lake longevity will slowly be decreased. So that is one of the biggest reason watershed managers must try to reduce the silt load or the sediment load. That way the longevity of the lake will be preserved for longer. And you can see here the results related to flow. We simulated from 2015 to 2025. It shows that it is not that much variation is there, but still you can find in 2022, 2023, there are some variations. 2018 has in January has one of the lowest your flow rate. Maybe the simulated one is explaining that this is the simulation result, this is not the actual result. So simulation is explaining that year actually less rain happened during the winter time, and it is actually varies, the result varies for every year. That would help the watershed managers to take wise decisions for managing the Lough Neagh water resources. And this graph shows that 2015 to 2025 sediment output load. You can see 2015 has the much higher sediment output load, and almost similar fashion over the 10 years it is happening, and the more expected again in 2024. This is the result, shows what other your output parameters we obtained, like your organic nitrogen, mineral nitrogen, organic phosphorus, CBOD, dissolved oxygen, and then nitrite, nitrate, ammonia, then different type of bacterial load. So all are available, but the initial run, the picture we showed here, it is the initial run when the process is kind of warming up. That is the reason a lot of data we see here as null. But later on, when model run after being warmed up, so it provided correct result, and you saw the figures over there earlier. We also obtained results for ammonia and nitrate, and also other nutrient loading, along with our sediment load and your flow rate, stream flow rate. Now, next step for us was to run this model through SWAT-CUP so that auto calibration could be done and the model validation could be completed. And as we know, SWAT-CUP actually uses SUPI2 modeling approach to calibrate the model, and we did not have the actual data of the watershed. And now, as I explained, Wyatt is doing his master's in Oxford, so he is in the process of collecting the actual result from the field. Then we can use the actual data, actual output to run the SWAT-CUP so that model can be calibrated well, and the final result will be validated with the field data that Wyatt is collecting. So that's our project. And finally, conclusion. The model was able to provide high-end representation of sediment and water runoff or the stream flow amounts, other nutrient loadings for the each individual sub-watersheds. This data is useful for watershed managers in Northern Ireland to support the proper management of Lough Neagh, the largest inland lake in UK, the source of 40% of the country's water supply, Northern Ireland's water supply. The study also provides for the development of Lough Neagh and Londonderry County watershed decision support systems. And we acknowledge Dr. Eric Morgan from Queen's University, Belfast, and Ordnance Survey of Northern Ireland, and US Geological Survey, and NASA Open Data Platform for helping us to get the data for the modeling and the model customization. And some of the references, SWAT reference, your Earth Explorer for Landsat 8 data downloading, and global weather from the SWAT database. So